Fine, guys, let's start. Okay, so yesterday we have started seeing the visualization matplotlib library, and we have seen the basic plots. Okay, like we have seen plt.plot basic plots. So now today we are going to see the next type of plot is scatter plots. Okay, so this scatter plot, sorry, yeah. So now this is the way scatter plots look like. Okay, so that as the name is saying that scatter, so it will just scatter the points, okay, over the space. Okay, whereas a plt.plot, fine, so where a plt.plot will not scatter, it will just join the each and every data points. Okay, so if these are the points, plt.plot will also join and will give you the graph. Okay, whereas a scatter will just give you the points, fine, without joining them. So for example, this is a weight cost. Okay, so if 10 is the weight, this is the cost. Okay, it will just point the points over the space, and yeah, and all the data points, as you can see, are scattered over the given graph. Fine, so obviously you need two variables to plot a scatter points, because any point in the space can be defined by two values. Okay, x comma y, on x-axis, on y-axis. So that's why it is helpful in bivariate analysis, that means two variable analysis, and both of them should be numerical. Okay, both of them should be numerical in nature for scatter plots. Okay, and the purpose is to find the correlation. So obviously once you plot this, and by just observing this graph, so this obviously looks like this both has some what positive correlation. Agree? So if you remember the graphs, so positive, negative, and zero correlation. Fine. So if you see a increase in the slope of the line, so that's a positive correlation. Fine. This is a negative correlation. So obviously, as the weight is increasing, the cost is also increasing. Fine. So as the weight is increasing, cost is also increasing. So just by looking at the graph, we can get an idea on the correlation between the two variables. Okay. So those are the advantage of the scatter plots. Fine. So now let me show you a few examples. Okay. So for example, let's say I'm just creating x and y randomly. So x is np.line space minus 10 to 10, 50. So we have already seen what is line space. Okay, it will create 50 data points in between these. Okay, that means from minus 10 to 10, this range, it is going to divide it into 50 parts, equal parts. Fine. And that is x, and y is for each value of x. Okay, so we are multiplying it with 10 and we are adding 3, and we are also adding something called as random integer. So we are creating a random integer from 0 to 300. Okay, 50, like that we are randomly creating and we are adding. Okay, so finally these are the values of x and y. Sorry, this is y. So if I just show you, yeah, so these are the x 50 values, and for each value we are doing this small operation, and these are the values of y. Okay, fine. So now, as I said, that to plot a scatter plot, we need two things, x comma y. Fine. So we have created x and we have created y. So the way how you can plot the scatter plot is simple: plt.scatter. Just like how we have done yesterday, plt.plot. Fine. So as I said, always focus on what I'm using after plt. Plt is what we are importing it from matplotlib, but focus on what we are using after PLD. So over here you have PLD dot scatter. Okay, and we are passing x comma y. Simple. So these are the values. Okay, so that means what? How it's plotting? It's taking first one value from x and one value from y. So this is x, this is y. So first value is minus 10, comma, over here it is minus 32. That will be 1 point. So it will be on x-axis, it will be taking minus 10. Okay, so on x-axis it is minus 10, and on y-axis it will be 32. Okay, so 0 somewhere over here, or possibly could be 32. Uh, 1 second, Karthik. Okay, so yeah, Karthik, any network issues? So if you, as you've seen here, the we'll just plot the each data point over the space. Okay, so over here x-axis and over here y-axis, and you can also yesterday the way how we have seen to add the title, to add the x label, to add the y label, all those things we can also do it over here also. Okay, those will be general concepts. Fine. So is this example clear, guys?
Yes, sir.
Okay, fine. So next, let's say let's take an example. Okay, so pd dot read csv batter, batter dot csv. This is how we are reading the csv. Okay, so these are the, this is the data frame. So what's the data frame? Let's quickly try to understand. Yeah. Name of the batsman, his runs, average, strike rate. Okay, there are 4 columns over here. Fine. So now, yeah. So over here now, if you see, I'm doing pld.plotter. So as you have seen, we need to pass 2 values. So over here, I'm passing df average. Okay, that means what? Df of average is okay, df average and df of strike rate. Fine. So plotting this, just doing this will give you, you will plot the, okay, the graph, scatter plot. But you can also customize few things like color. You have something called as color. Okay, the this color, red color, and also marker. Fine. So place, there are so many markers those are available. Okay, you can choose. Fine. So once you do that, and as we have seen, you can also add title, you can also add X label, Y label. Okay, so now this is much more understandable. So here it is talking about average and strike rate answer top 50 batsmen. This is average, this is strike rate, and as you can see, someone is having the highest strike rate, but average, okay, but this guy is having super average, but medium strike rate. Okay, so this is a way how you can plot it from the data frame. And if we just run this, what I'm getting, average is not found, why it is not found. Let me just run this. Okay, so okay, you're getting black, right? Fine. So let me, this is the background, we can set it. Okay, I'll just show you in a while. Okay, fine. So these are the values. Fine. So I would say green, if I go for green, yeah, as you can see green, and instead of place, if I go for star, something like that. Okay, fine. So you have a lot of options available also. So that plot for the scatter plot, simple. You can just go over here and say Matplotlib scatter plot marker. Okay, so there are different types of markers. So yeah, see 0 greater than 1, 2, 3, 4, 5, 6, 7. It's saying that if I give 4, 8, it is giving octagon, something like that. Okay, you can try that. Go here. Yeah, it's good. It's giving me the it's not a circle, it's a small octagon. Okay, so coming to colors also, you can choose from the documentation. Okay, so this is a official documentation of Matplotlib. Okay, you can choose. Fine. Is this clear, guys? Following? No. Next, fine. So next, let's see, we have a data frame called as tips data frame. Okay, where you are having total bill. Okay, how much is a tip and what is a gender, sex, male or female, and whether it is smoker, day, time, size. Okay, how many people have had the dinner. So from this data set, so if I'm taking total bill, okay, so if I'm taking total bill and the tip, fine. So this is a plt.scatter. Okay, so this is a x and this is my y. Okay, and if you see one new thing over here, he is saying s equal to tips of size. Okay, tips of size, that means this column into 20 I'm doing, and this is a new parameter. Agree? So usually we just need two things, one is x and one is y. Agree? We need only x and y, but this s parameter here stands for size, guys. Okay, now what is the size? The points whichever you are plotting over here, right? The points which you are plotting over here, the size of these points. I want the size of these points also be based upon this column, because I don't want every point size to be just a single point. If the value is small, it can be small. If the value is big, it can be big. Getting? So the size of these points can also be customized using this parameter called as S. Okay. So over here, as you can see, some points are small, some points are big. Getting? See, this is big, this is small. Okay, this is average. Okay, this is small, big, very small. Getting? So these sizes are coming from, I'm taking it from this column. So I'm saying S to S, what I'm passing T of tip size into 20 I'm doing, because these values are 2, 3, 4 are very small. So into 20 I'm doing. So when you're doing into 20 for every value, so again, we are treating all of them equally. Okay, so 3 will become 60, this will become 40, 80, like that. Fine. So, and these are the values. So just by looking over here, based upon the size also, we can understand. Fine. So which particular person has given more tips. Okay. Is that clear, guys?
Yes, sir.
Okay, fine. So after that, fine. So for example, if I show you over here, okay, let's try to do it over here. Okay, so here the graph is, yeah, why see, that's a good example. So when I earlier just stepping one step back, okay, so in this example, so we have plotted using plt.scatter. Okay, so scatter will do this. When you use plot for the on the same example, you will have a graph like this. Okay, so this is not making any sense. Agree? So here what I'm trying to show here is when to use plt.plot and when to use scatter. Okay, see, you can use any graph, but if, but obviously it should make some sense out of it, right? Because over here, for this example, if I use plot, it works because it is giving you a good representation. plt.plot, we can understand what's happening. Okay, and scatter will also work here. Okay, scatter might also work, but plot is much more helpful. Agree? So instead of just seeing the points over here, but instead of only that, if we have a continuous graph, so we can get an idea of the what is the nature of this batsman, Virat Kohli or Rohit Sharma, right? In which areas years he is performing well and which areas he was not in form. Fine. So here PLT dot plot will be the best choice. But if you come over here, okay, in this example, it will not work. PLT dot plot will not work because if you see the graph, it's not making any sense. Fine. Why? Because here we are plotting against two variables. Okay, so earlier it was only one variable. It was regarding about the it was regarding only about the Rohit Sharma. Okay, so but over here it is about the particular one is average and one is a strike rate. Fine. So that's the reason here plot doesn't make sense. It's not helpful. Okay, but scatter plot will be more helpful. Okay, so that is one way. And the other thing which I want to show here is in the same example, what we have seen just now. Yes, okay. Yes, there is a parameter called as yes. So we can pass here yes. As of now, I not pass any parameter yes. Fine. So that's why every I would say the plot, the dot is of same shape. Okay. So I will pass. Okay. S equal to so what we done average and strike rate, right? So let me comment this. Okay. So average and strike rate is done. So that means average and strike rate is done. So let me take this runs as my, as you can see, runs are also varying, right? 6, 5,000, 4,000. Okay. So let me take this runs column as my size column. Okay. So how can I do that? I'll do df of runs. Okay. Yeah. So yeah, it's completely fine. So I will divide it by 100. Will that work? Yeah, this works. Okay. So or divided by 50 also might be a better option. Huh. So as you can see, so this guy, if so we are plotting, so we are using all the three columns from the data frame, guys. We are plotting on the average and the strike rate of a particular batsman. Okay, let's say this is Dhoni. Dhoni's average is somewhere around over here and his strike rate is over here. Okay, then okay, for example, let's go for the actual Dhoni itself. Where is Mr. Dhoni? Yeah, 7. Okay, so here it is 39, 130. Okay, average 39, strike rate 130. Okay, I cannot exactly say, but 35, 39 over here. Okay, and 130. Okay, so this guy, this is Dhoni's. Okay, so as you can see, the size of the plot is also bit bigger. Okay, why? What is a runs? See, 4978. Okay, so because we have so many batsmen who's scoring very less than him, so 1900. Okay, looks like this data frame is sorted on the runs column, guys. As you can see, it's sorted on the runs column. Okay, fine. So he's almost at the top when compared on the 50. So he's almost at the top. So that's why his graph is his plot is bit, or what do you say, bigger. Okay, but if you see this one is very small because he scored less runs. Okay, the size of this plot, this dot, is based upon his runs. Okay, so obviously it is helpful, right? So instead of having every dot have the same size, we can use one more column and also plot. Fine. Are we clear with this example, guys? Are you guys following?
Yes, Santosh.
Okay, fine. So that's about so we have seen scatter plots, simple scatter plot, and after that we can also customize with the color and the marker, and then just giving some labels like title, X label, Y label, and also the size of the dot. Okay, so all these are choices, guys. If you don't want to use this, that's fine. So you can go with the same size also. Okay, so color by default it will take some color. Green it by default it can take. Okay, so these three also not mandatory. Okay, the only thing mandatory is plt dot scatter and pass some X value, pass some Y value. Okay, but using this will make your graph more representable. Okay, so that is also recommended. Okay, fine. Let's move ahead. Okay, so that's regarding the scatter plots, guys. Fine. So from practical purpose, I would say scatter plots are very important. Okay, because the first thing we want to see between any two columns is whether they are correlated or not. Okay, because I think I've already mentioned it, but I'll just tell you a small brief. What is the whole point of machine learning? Machine learning is to make some predictions. What is that? So if I change some, given a set of inputs, what will be the output? That means what? If I change this input, how my output is changing? Fine. So for example, if my number of the square foot, okay, if the house square foot, or for example, if the um if my salary is increasing, okay, every year, so what is the effect of my expenditure? Okay, or if my interest rate, EMI rate, a loan interest is increasing, what is the effect on my lifestyle? Okay, some based upon some input we are going to predict the output. So that means when we are predicting means there should be some relation between these two, right? Fine. So that means at least these two should be somewhere correlated. That means if it is increasing, it should increase or decrease, or positive, negative, or some correlation must be present. If there is no correlation at all, fine. So then what is the point of machine learning model or anything? For example, let's say my salary, and a simple example as my height. Agree? So obviously there is no correlation at all. Fine, whatever be the changes in my salary, my height is going to remain constant. So even if you use machine learning or deep learning or any model, right, so you cannot predict what column based upon other column. That means the correlation is zero. Fine. So that is the fundamental thing you need to check. Fine. So whenever you're working on any machine learning algorithm, or mostly classification algorithm, okay, in clustering we don't use that, so we will see that. But generally speaking, first thing we'll see is whether two columns are correlated or not. Okay, so how you are going to do that? Okay, so using functions, so using pandas CORR graph, yesterday we have seen, right? So using this you can, yeah, where we have seen, yeah, we have seen this in the pandas profiling also in yesterday class. Okay, so using this you can get an idea. Okay, or by plotting some graphs. Fine. So, and one simple way is scatter plot. Okay, take these two columns as scatter plot. So if I plot my salary and height, so it will be what? So it will be constant, uniform, because whatever be the salary increase in the salary, the height will be always constant. Fine. So obviously there is no correlation. Agree? So that is the importance of my scatter plots. Fine. So, and the plotting is very simple. Okay, fine. So after that, so these are the basic, but still you can have so many parameters. Okay, so in the scatter plot itself, I've said marker, but these are more than enough. Okay, so no need to make our graphs so much fancy. Okay, so but whatever we studied, right? So this is enough for you to plot any scatter plots. Okay, fine. So after that, what we have is a bar chart, and also the next is something called a histogram. Okay, I guess bar graphs and histograms are not very new to us, because we have seen quite a few in our statistics module. Agree? Fine. So if I just have a quick review, bioanalysis, is it in the univariate? Yeah. So over here, if you see in the univariate analysis session of our stats module, so we have seen the bar chart and histogram. Okay. So we are going to see how we plot them, but just to give a quick recap. Bar graphs, okay, will have spaces in between them, guys. Okay, they'll have spaces in between them, as you can see. Okay, but in histogram there will never be any spaces. Why? Because histograms are plotted for a continuous variable. Okay, and whereas the bar plots are plotted for the discrete. Okay, that means what? Each of this graph, okay, each of this bar is representing a particular column. Okay, so over here, for example, if I, are you able to see this? Or yeah, so over here if you see, this is what EastEnders, this is casualty, this is peak practice, this is the bill. Okay, so each bar is representing different columns, and this is the value of that particular column. Okay, and these are discrete. Okay, fine. So over here, what is this? Number of viewers. Okay, these are number of viewers, and these are some categories. Fine. But whereas coming to the histogram, okay, coming to the histogram, it is continuous in nature. Why? Because it is plotted for a single column. As you can see, age. So what is the distribution of age? Fine. So when you are having an age column, so obviously there should not be any gaps, right? So what the whole column, whatever you are having, right, that we are plotting in the graph format. Okay. So from 5 to 10, see, and plotted against the frequency. Okay. So and plotted against the frequency. That means what? So from from age 5 to age 11, there are only 1%. That means from 5 to 6 age, there is only 1%, 6 to 7, 7 to 8, like that. From 5 to 11 age, number of persons are only 1. Okay. And from 11 to 16, number of people are 3. From 16 to 18, number of people are 2. Fine. So you need to cover each and every age that is present in the graph. Fine. So that's why it will always be continuous in nature. Okay, the whole whatever the column you are giving, right, so that will be considered and there will not be any gaps. Okay, the first thing how you can differentiate between bar plot and histogram is you can have a look at the gaps. If there are no gaps, mostly it is histogram. Okay, fine. And this is continuous, this is discrete, and the x-axis will be, so y-axis will be frequency over here. Okay, fine. So that is just a brief. Now let's try to see the actual graph. Okay, fine. So yeah, so this is a bar chart. Okay, favorite color and children. Fine. So how many, see, this is a favorite color. Yeah, so this title is favorite color. Okay, so I'm plotting colors and children. That means what? 8 children, 8 kids are liking red color, 7 are liking blue, 5 are liking green, like that. Okay, so all these are different categories. Fine, and you can see clearly the gaps between them. Fine. So and these are discrete. Fine. So it's like 8, 5, 6. So these are discrete. Okay, and this is a frequency. In on the y-axis we are plotting frequency. Fine. So that's why it is a bar plot, bar graph, you can call it in which way. Okay, so discrete and having spaces in between the graph. Okay, so this is a small example. Fine. Now let's try to see the actual how you can plot this. Okay, a simple example is children. Okay, I'm taking children in the color as you've just seen. Okay, so bar colors. Okay, so you can also see if I don't give any color, let's see what it will give. Okay, so see guys, graphs are very experimental, I would say. So you can experiment a lot of things because there's so many parameters which we're having. Okay, so by default it is giving me black color, but I don't like black color for it. And let's say I want some red color. Okay, so red color. Okay, green. Okay, green. I'm just guessing if you want multiple colors. Okay, will it work? Okay, so you can just experiment, guys. Okay, there's nothing wrong. See, it's giving. I can give 2 colors also. So what? Total there are 5 colors. So if I say some yellow, yeah. So it's giving red, green, yellow, like that. So I can also give any other color, pink, and any other color. What? Orange. White. See, red, green, yellow, pink, orange. Fine. So like that you can experiment, guys. So now just I'm thinking, what if I give one more extra color, what will happen? I don't know. Just see. Fine. It's not giving. So that means if at all there is one more bar over here, so that will be used by the green color. Okay. That means what? If I go for 100, okay, and if I go for some, okay, then it is going to use a 100. Agree? So this is simple bar graph. Is this clear? Are you guys following?
Yes, sir. Clear.
Okay, simple. Fine. And also this is, oh, main thing, as I said, you need to observe here is pld.bar. Okay, so we have seen pld.plot, pld.scatter, and pld.now bar. Okay, and also next we have also something called as bar h. That means horizontal. The same graph will be plotted in the horizontal fashion. Okay, so this is vertical fashion. So as if you see bar H, the same graph will be plotted in the vertical, sorry, horizontal direction. Okay, here also again you get customize and play with the colors. Fine, simple. Then after that, let's say we are using this data set called as batsman season record, and this is a small data frame, batsman 15, 16, 17 years. Okay, and where did we use this? Yeah, so data frame df, this is df, and a range of df of shape of 0. Okay, so see, let's try to understand what we're doing over here. Okay, see, uh yeah, so it is a bit different. I would not say different, bit advanced bar graph. Okay, see here what's we're doing. This is a data frame, right? So what I want to do here is for each and every batsman, I want to plot for all the years. That means first, let's say Dhoni. So for Dhoni, I want to show what is 2015 ka graph and 16 ka graph and also 17 ka graph. Okay, and here for Kohli also. So let's say Virat also 15, 16, 17. Okay, in the same graph, I want to plot three graphs for each batsman. Okay, so that there what at one shot only I can get a clear idea for everything. Like I can also understand what is the individual performance of this particular batsman, and also I can do a comparison between different batsmen from single graph itself. Okay, fine. So for that, what we are going to do, see here. First, the way how they are plotting here is, see, plt dot bar. Okay, so what they're plotting over here is np dot arrange df dot shape of 0 minus 0.2, and we are plotting df of 2015. Okay, so don't worry, what they are doing is very simple. See, I want to plot, for example, for Dhoni, I want to plot three graphs. Okay, so for that, what we are doing here is, first thing is, see, np dot arrange of df of shape 0. What is df of shape 0? What is df shape? Df shape is simply the shape of this particular data frame. What is that? It is number of rows by number of columns. Okay, what are number of rows? 5 comma 4. Agree? So 5 comma 4 will be the, see, if I just show you shape, df of shape 5 comma 4. Okay, now 5 comma 4 is a, what is this? This is a tuple. Okay, now if I take 0, I get 5. Okay, and when I do np dot arrange of this 5, okay, df of shape, what I'll get? 0 1 2 3 4. Agree? Simple. So we got 0 1 2 3 4. np dot arrange of df of shape 0 will give you 0 1 2 3 4. Okay, so those positions, that means I have 0 1 2 3 4 positions I have. Okay, so 0 1 2 3 4 or let's say these are some positions on a graph. Okay, I'm plotting. Fine. So just let's say this is what for one particular year. Okay, how many years we have? We have 15 16 17. Okay, this is for 1 year, and just I want all the three graphs to be side by side. Okay, for 15 16 17. Okay, all three graphs I want to be side by side. So what I'm doing over here is I'm using these positions for 2016. Okay, and just beside this I want for 2017. Okay, and over here I want for 2015. Okay, so that's why what I'm doing over here is it's very simple. So over here, if you see np dot arrange of df shape of 0. Okay, the actual 0 1 2 3 4 I am using for 2016. How? If you see, for 2016 I am using np dot arrange of df of shape of 0. Okay, that means 0 1 2 3 4, these positions I am using it for 2016. To the left side of it I want to plot. Okay, this is just a position, guys, not the graph set. Okay, to the left side of this I want to go for 2015. So that's why I'm doing just minus 0.2. Okay, so I will take just minus 0.2 means what? Minus 0.8 position I am occupying it for another graph, for 2015 graph. Okay, so here also 1 minus 0.2, 2 minus 0.2, like that. Okay, so over here it will be 2015 graph. Okay, and np dot arrange of df shape of 0 plus 0.2. That means over here 0 plus 0.2. That means 0.2. Okay, 1 plus 0.2, 1.2. Okay, this position I am using it for 2017. Same to 0 plus 0.2 plus 0.2. Okay, so that's how we have created the positions. Okay, positions for these three graphs. Okay, and after that what we are plotting, that is simple df of 2015, where over here wherever you are using minus 0.2, there we am plotting 2015. The actual I'm using it for 2016, and wherever you are using plus 0.2, that I'm using for 2017. So that minus 0.2, that means the first one will be 2015 one, next the actual one 2016 one, and the next one plus 0.2 will for the 2017 one, and same thing for every batsman. Okay, and the width you can also do 0.2 or 3 will show that, and color you can use different colors. Okay, so that's how, as you can see, first 2015, that means what, see this np dot arrange of shape of 0. Okay, so those are what are the values of this np dot arrange of shape of 0? 0 1 2 3 4. Okay, that means what, so these will be 0 1 2 3 4. Which one? See, this red will be 0, this is 1 2, again this red 3, this red 4. Agree? And after that I'm doing for the same thing, I'm doing minus 0.2. Okay, now minus 0.2 means what? It will 0 minus 0.2, that means this position, all yellows. Okay, after that I'm doing plus 0.2. Okay, plus 0.2 will be what? All these blues. Okay, these three positions I am just specifying to plot some graphs. Okay, now what graphs I want to plot? So for the red I am say, so for, if we start from the first thing minus 0.2, I am plotting 15. Okay, so first it will plot just all the yellow graphs. Okay, it will just plot all the yellow graphs. Okay, after that it is going to plot red. Okay, so after that it is going to plot the blue. Okay, so don't think first it will complete this, next this, next that. Okay, no, it will go by line, right? So this particular line first it will execute. So when it executed, all the yellow plots will be appeared. Okay, next the red one, next the blue one. Is this clear, guys? Did you guys follow this example?
Yes, Santosh.
Yes, sir.
Okay, oh great. Okay, so that's how. Okay, for example, if I just show you, see, getting now. First, when I run this, only all the yellow lines will be created. After that, when I run this, red also got created. Okay, after that, when I run this is created. Okay, if I don't use this, for example, if I don't use minus 0.2, if I use the same thing, okay, see, they got overlapped. Red and yellow got overlapped. See, here also you have yellow, here also you have yellow. Okay, but it is overlapped by red. Here it is visible because yellow is greater than red. That's why. So here yellow, all this here yellow is less than red. So that's why it is somewhere over here. It's got overlap. Agree? So just to avoid that, what we are going to do here is we are taking different positions. Okay, minus 0.2 plus 0.2 like that. Getting? I hope that's clear. So with this example, so this is a basic example. So you can extend this to any number of columns, guys. Okay, so you can think of this as sales. Okay, a company, let's say a Cadbury company, so it want to analyze the sales of different years, last 5 years. Fine, so the one could be, this could be 2015, 16, 17, 18, 19, 20, 6 years. Okay, like that. So a single graph will be let's say just 3 years simplicity. Okay, Cadbury 3 years. Okay, 17, let's say 20, 21, 22. Fine, 3 years. And let's say across different locations, Hyderabad, and now say Chennai, 20, 21, 22, Kolkata, 20, 21, 22. Okay, so you can get a very good graph, right? So by checking only, by looking at the graph only, you can understand which particular location is having the highest sales, okay, and lowest sales, okay, and also each location also which one is having the better sales. Fine, and you can also go to one level down in each year. Also you can go for monthly sales. Okay, that will be more helpful because in which particular season the graphs are increasing. Fine, is it in the summer, is it in the winter or raining? Fine, and in which location, for example, in Hyderabad, whether it is summer, and if it is Bangalore, if it is winter. So obviously you can do some analysis, right? So why people are buying more Cadbury chocolates in summer in Hyderabad? Is it due to what? Due to some, I don't know what would be the reason. Or let's say if in summer, if you're having, let's say, February, and if you have Valentine's Day, and is that the reason why right, there is a like sudden rise in the sales in the Cadbury chocolates, something like that. Okay, I'm just giving example. Okay, in Bangalore there might be due to some other reason. Okay, so those analysis you can do it from a single graph. Okay, so this is how you can plot a single bar graph. This is a multiple columns bar graph. Okay, I hope this is clear, right? Okay, fine. So after that, next thing is also names. Okay, so simple. So it's the same thing. The graph part we understood, right? So next thing what we have is called as plt.xtix, rotation equal vertical. So the names, right? So usually if the name is, see, if the name is small, so it's fine, but if the name is very big, so there will be overlapping of names, right? So that also you can customize. You can say rotation equal to vertical, so the names will be in the vertical position. Okay, and again same thing, you can use title, everything what all we have studied, right? So everything you can put in one graph. Okay, we're studying step by step. Fine. So after that, yeah, this is one more interesting graph. So over here we have drawn 15, 16, 17, okay, in 3 different graphs. Okay, but if you want to see all of them in only one bar, okay, so we have used 3 different bars, okay, for single batsman. Fine. But if you want to go for only single bar, okay, and single bar for each batsman, and you want to specify. So over here what we are doing, if you see, yeah, so if you see, first you are drawing plt bar, okay, batsman 2017, I'm saying label 2017. Okay, why I'm using label over here? Because I'm using only single bar, so I need to go for something called as legend. Okay, what is legend? This is legend. Yesterday we have seen, right? This is legend. Okay, how it will be displaying because of this line, plt.legend. Okay, see how I'm going to plot this graph in only single. Okay, so first thing is I'm plotting plt dot bar day of batsman 17 label 17. That's fine. But after that, what I'm doing over here is next for 16, I'm also plotting 16, but I'm saying bottom equal to df of 17. Okay, so bottom equal to df of 17. Okay, or the left, whatever be the left out space, that will be filled by 2016. Okay, you will understand. Give me a second. Okay, for 15 I'm plotting batsman and 15, but I'm saying the bottom will be 16 plus 17. Okay, so in the bar 16 plus 17 will be at the bottom, and whatever will be the left, that will be given by the 2015. Okay, so what it will do, first it will fill 17. Okay, first it is going to plot 17, and now coming to the 16, so it will fill on the same thing, but it will put 2017 at the bottom, and remaining will be filled by 2016 in the second step. Okay, the second step. Now when the third step is entering, so it will put to 16 and 17 at the bottom, and on the top it will go for the 2015. Okay, it will do for every column. Okay, so if I just run this, oh, so color codes got mismatched. Okay, this is actually coming from this one, and what will be the default style use? Okay, just give me a second. Matplotlib default style color. Okay, it's a Virdis. I think it's Virdis. Do we have something called as Virdis? Okay, style.use default. Oh, what did I get? Okay, now let me try particular graph. Okay. This might be better. Let me see. It's just color coding, guys. Don't worry. Yeah, this works. Okay. So over here, if you see in the same graph, so we have got three things. Okay. So if you see over here, see, if I for first line, it is having complete 2017 itself. Okay, so after that in the on the same graph, okay, so why it is plotting on the same graph, guys? Because I did not specify any positions. Okay, earlier if you see, I have clearly, I don't want the overlapping part, so that's why I have created different positions for minus 0.2 for df and plus 0.2. We have created the positions. Okay, but now since I want to do it on the same single graph bar, I'm using same thing, but what I'm doing, I am using something called as bottom. Okay, the variable parameter bottom. I'm saying first I plotted 17, put that at the bottom, but now plot 16 in the remaining part. Okay, and based upon the bar itself, so it will divide it into what till where you are having like 17. Okay, for example, let's say AB de Villiers. Okay, now AB de Villiers, what is this 17 and 16? 17 is 2216. Okay, and remaining is 687. Okay, 216. Okay, so over here if you see ABDLS, this is 200, right? So this is just above, it will be 216. Okay, till here that will be 216 and remaining will be 2016 graph. This is for 216 is for 2017 graph. Okay, similarly this will be for 2016 graph for Warner. Fine. So now if I do one more thing also, so what I'm saying here, I'm saying put the combination of 16 and 17 at the bottom, but now plot 15 also, putting this on the top. Okay. So now if I run this, see, so 17 and 16, blue and green are on the bottom. Okay. And at the top, we are plotting 2015. Okay. 15. Got it? Is this clear, guys?
Yeah, Santosh.
Okay, so this is different ways how you can plot a bar graph. So in bar graph, we have seen simple bar graph and color codings. Okay, and then horizontal and vertical part, and how you can draw multiple bar graphs for different years categories in single, and also how to utilize only one single bar for different ways. Okay. So there are two more simple graphs appending. So I just like want to ask Meghana, today, Sirisha, today there's no college, right?
No, sir.
Okay, so we'll be extending a bit. Okay, so I don't think these are simple graphs only. That's why I don't want to take one more session. So tomorrow we have one more library called as Seaborn. So let's conclude this graphs today. Okay, so it will take just like I would say 20 more minutes. Is it fine? So shall we continue?
Okay, sir.
Okay, fine. Fine. So I hope that the reason I'm continuing is these are not too much, okay? Because in stats, if we extend, right, so that may be difficult to understand, but I've seen these are simple graphs, okay? So we can cover it in maximum in this class, okay? So fine. So the next thing is histogram, fine. So coming, or do you guys need a break of a few minutes? No break? Okay. Or you want? Tell me, guys.
No, sir. We can continue.
Okay, great, fine. So next thing is histogram. So okay, just now we have seen the histogram part, so which is a continuous in nature. Okay, so over here, if you see, Yeah. So data. So a simple histogram is the way how you plot the histogram is PLT dot hist. Okay, hist, and this data, and these are the bins I am using. So what is the bins from 10 to 25, 25 to 40, like that? Okay. So we will see by taking example, but these are the simple histogram bins. Okay, so it has always been continuous in nature. So that means from 10 to some 40, what is the frequency? Okay, and some 40 to 55, what is the frequency, and 55 to 70, what is the frequency? It is mostly on the frequency type. Okay, on the y-axis it will be the frequency. Okay, so fine, we'll look at some example. Okay, so we are having some data set called as VK. Okay, so match ID and Batman. Fine, so over here if you see, I am plotting DF of batsman. Okay, on what bins? So these are the bins. Bins means what? How you are going to divide the x-axis. Okay, so here from 0 to 10. So okay, so from 0 to 10 you can see this 0, this is 0 to 10. Okay, and then from this is 10 to 20, or let me put it over. See, this is 0 to 10. Okay, this is 10 to 20. Now 10 to 20 to 30. Okay, like that, for at the range of 10. Okay, so we have till 120. Okay, so on this graph, so I want to plot. Okay, so that means what? So from 0 to 10, okay, what is the frequency? Fine, so these are the runs, right? So overall these are the runs. Fine, so what I'm plotting, I'm just considering this batsman runs. Okay, from batsman runs, so the way how you need to understand this graph is, the first graph, this is saying is how from 30 to some, let's say this is what, 33 for example. Okay, now, and what is this bin? This bin is 0 to 10. Okay, that means from here to here. That means 0 to 10 in this range. Okay, there are like 33 scores. Find the frequency is 33. That means there are 33 scores which are falling in between 0 to 10 range. Okay, so that means, see, that 0 to 10 in the sense what? See, this is 0, right? So like that, you will have some scores which are less than 10 and greater than 0. Okay, 0 to 10. Okay, in this range. Okay, in this range you are going to have 33 is the count. Okay, so that is a frequency over here. For example, over here if you see this, what is this? This 0 to 10, 10 to 20, 20 to 30, 30 to 40. Okay, so 30 to 40. So this particular is saying scores that are between 30 to 40 are how many? Somewhere around 22. Okay, so there are 22 scores which are falling in the range of 30 to 40. Okay, so that's what it's saying. So that's why it is continuous. So every score we'll convert it into bins, and we'll say from 10 to 20 what is the range. Okay, the frequency. Okay, so here we are not plotting the actual values. Okay, the difference between the main difference between the bar and histo will be, in bar you might plot the actual values. Okay, for example, if you see over here for MS Dhoni, or in any other simple case. Okay, so for red is how many? Okay, 10. Blue is actually how many? See, red is 10, blue is 20. Fine, blue is 20, green is 40. So the actual value whatever you have, so we are trying to represent that. Okay, the length of this particular bar will actually represent the values. Agree? But coming to the histogram, it is about the frequency. Okay, so it is about the fundamental thing is about the frequency. Okay, so bar can also be sometimes frequency. Okay, so as you can see over here, in bar, okay, it could be number of, mostly to the number of people, or the count, actual count, or frequency. Okay, it could be number of people, or sometimes could be frequency. Okay, in our case, the bar graph, it was actual number of people. In the case, what number of people in the sense the count. Okay, so there we had the runs or something. But coming to the histograph, it will always the frequency density. Frequency density is what? That means in this range, what is the density of the frequency? That means from 10 to 20, what is the frequency? How many people are falling? Okay, that means from 50 to 60 range, that means how many people from the overall given data set have scored the runs between 50 to 60, that frequency, right? Let's say 25 people have scored runs that are falling between 50 to 60, that means 50 to 50, something like that. Okay, that frequency we are going to plot it on the y-axis. It's called frequency density. Why? Because for each range it will give you the frequency. Okay, so that's what we are trying to see over here also. Okay, so now that's the reason you will have this is a continuous in nature. Okay, and next thing if you see over here is, yeah, so the next thing which you see over here is we can also convert the bins into log bins. Okay, so yeah, log equal to true in the sense it will convert the 10 all these bins into logarithm values, and the same thing histogram, the frequency can be plotted. Okay, so we are going to see all these different type of graphs in our mainly the next model itself, the feature engineering. More than feature engineering, we are going to see in the EDA, exploited data analysis, our next to next module. Okay, so there we will be having more practical understanding also, because we will be taking a particular use case and we are trying to understand. Okay, so those are the just few examples of histogram, guys. Okay, any doubts in histograms, guys? Are we good?
Fine, Santosh.
Okay. Others?
Sir, no doubts.
Okay. Just checking. Okay. Fine. So I was just trying to show you the same thing. So over here, if you see saying that from 0 to 10, if I just tell you what this is around 30 something, 30 place, right? So 33 or something example. Okay, so the same thing when we go to the graph and put it over here. Okay, so see, so when I consider the plots 0 1 2 3 4 5 6 7 8 till 9. Okay, fine. So it is 0 to 9. So yeah, in histograph, one more thing I would say is it will be always, when I say 0 to 10, so that means from 0 to, it will consider 0 to 9. Okay, and 10 to 20 means it will consider 10 to 19. Okay, so the first will be exclusive, second will be inclusive. Sorry, first will be inclusive, second value will be exclusive. Okay, fine. So now from 0 to 9, if I consider, so as you can see, if I select 0 to 9, so I got around some 33 count. Okay, so the same thing it is saying is from 0 to 33. Getting? Okay, so for example, if I go for this thing, what is this? This is between 40 50, this is 50 to 60. Okay, so this is 50 to 60, that means what? 50 to 59. Okay, so if I just deselect everything and if I go for 50 to 59, I'm having around 15 values. Okay, so that means what? It is saying from the given data set, the number of values, number of scores which are falling in the range of 50 to 60 are this count. What is the count? Count is 15. Okay, so that's why if you see over here, so this is almost equal to this. Okay, almost near to 15. Getting? Same thing for this anything you can take. So this is the frequency density. Okay, and these are the bins. So now you can customize the bins also. If you don't want to take 0 to 120, you can take 20, 20, 0, 20, 40, 60. So what happens? The frequency will increase because you are clubbing 10, 0 to 10 and 20. So there will be no more people in each range, each bin. So the bars will be a bit longer or the scale will be different. Okay. That's how you can understand the histograms. Fine. Fine, guys. Okay. So next last concept over here is pie chart. Okay, very simple, very interesting. Okay, pie chart. Okay, so let's try to quickly understand here. Okay, so in pie chart it's mainly helpful for univariate, bivariate, but here the usefulness is it can plot for categorical versus numerical. Okay, categorical versus numerical. That means for each category, okay, you can plot different categories and also what are the values of each category. Okay, that means for example 7th class, let's say 10th class inter, okay, and what is a BTech and MTech. Okay, what are the percentages? Now these percentages are numerical in nature. Agree? These percentages are, let's say 80%, 90%, 100%. These percentages are numerical in nature. Getting? But what are these? These are categories. These are categories. So you can plot a pie chart where it can have different what do you say, what do you call these pieces? Okay, different pieces representing each category, and also it will, the shape and size of these will represent the its numerical values, the corresponding values. Okay, we'll see examples, but the main thing is it is helpful to plot categorical and numerical, but you cannot do the same thing with scatter plot, right? Scatter is for only numerical and numerical. Okay, bar also you can do for categorical and numerical, right? For yeah, so for this batsmen are categorical in nature and their corresponding values are the numerical. Okay, so pi will also let you know in the categorical numerical example. Okay, so fine, let's see some examples. Okay, see, simple data we are taking over here. So data 23, 45, 100, 20, 49. Okay, 4, 5, 6. Fine. So 23 is for engineering, 43 science. Okay, all this agree. It's a simple, very simple. There are so many parameters which we have. So very interesting. So very simple and very interesting. Okay, it will be fun to learn pie charts. Okay, we are going to see quickly. Fine. So as you can see, simply what we have done, it has given a pie chart. Okay, and based upon this size. Okay, and the size of this got adjusted. If you see that, so let's say the maximum is what for third one. 100 max. Agree? So that's why ignore the color, guys. Okay, we did not specify any color, so that's why it is taking its random color. Okay, but the third one, let's focus on sizes now. So 100 max, so that's why the max is having the biggest size. Okay, and the least is 20, that is for SST. See, SST is having the smallest size. Okay, remaining are this. Okay, getting? So it is a SST. So max SST based upon the sizes it has considered. Just clear, simple. The main thing you need to focus here is pld.py. Okay, so very simple. pld.bar, barh, hist, scatter, plot, pie, simple. pld.x label, y label, title, everything, legend, simple. Is this clear? Simple pie chart.
Yes, sir.
Okay, so now we can do so many things on this. Okay, it should be very interesting. You see, that is simple, right? So after that, okay, so by default, see, by default it will be, see, this is an example. So over here what I'm doing, very simply I'm doing, so I'm saying labels equal to this. Okay, and values are these. Okay, so what it will do, I'm not doing anything, I'm just plotting this. Okay, so when I plot this, what it is doing, it is giving G1, G2, G3, G4, G5. That means G1, G2, G3, G4, G5. Okay, and these are the values, and based upon the values it is filling some colors. Okay, that's fine. But one thing you need to understand here is by default the pie chart will plot on the counterclockwise. What is counterclockwise? Anti-clockwise. Okay, this is clockwise, right? This is clockwise. Fine, this is anti-clockwise. Fine. So that's why it is going in the anti-clockwise direction. Okay, G1, G2, G3. By default, it will use anti-clockwise. Fine. The way how it is plotting the labels I'm speaking about. Okay, but if you want to change that, you need to use counterclock equals to false parameter. Okay, so where you are using these labels, right? So how you are plotting? Okay, so first is labels and its values. After that, PLD dot subplots. Okay, what are these? We are going to see it in detail in our next Seaborn examples. Okay, but here I'm saying what we are trying to do here is you are using the same graph, but you want to plot different. See, this is a different graph. This is a different graph. All these are different graphs, guys. So these are multiple plots we are plotting in one graph. Okay, so that's why you need to use PLD dot subplots. Okay, so PLD dot subplots will actually give you. Okay, so for example. Yeah, so fine. I'll try to show it in the next class. Okay, but don't worry, this PLD dot subclass will give you a facility to draw in one single graph. Okay, this pi is only one single graph. So in that we are trying to draw multiple subgraphs. Okay, so for that you need to use this subplots. Okay, so using this AX. Okay, so using this AX dot pi. Okay, AX dot pi. So you are going to use value, the what are the value you are using, and the labels are labels. Okay, earlier it is different. So earlier you are just having a sample data and subjects, and you can directly use PLD dot plot. Okay, but now since we need to use certain parameters, okay, which we are going to see just now, just in a few moments. Okay, so let's use in this format. Okay, so we are using from the subplots, and from there we are using AX dot pi. Okay, so here by default it will be clockwise. If you don't want in this AX dot pi value is these are the values, label is these are the labels, and counterclockwise equal to false. When you use counterclockwise equal to false, that means it will be in the clockwise direction. Okay, that means what? G1, G2, G3, G4, G5. Earlier it was this way, G1, G2, G3, this way. Okay, so this is regarding the clockwise plotting of the pi graph. Clear?
Yes, Santosh.
Okay, simple. So after that, partial pi. Okay, because if you see here, one simple thing over here is here, if you observe the value, so all these values sum up to 100, I think. Okay, so if you quickly see 30, 40, 50, 60, 70, 80, 90, 100. Yeah, so all this plot up to 100. So in other words, if you see in the pi plot, what is this, guys? This is the circle, and in this circle, what is the how many degrees a circle is? 360 degrees. Okay, in this 360 degrees will be considered as 100%. Okay, so in this 100%, how you want to divide? Okay, 12 percentage will be given to some, and 22% will be some 16. Okay, so all of them will be combined into 100%. Okay, so this overall 360 degrees, okay, it is going to divide 12% of this 260 degrees, 360 degrees will be given to G1. Okay, this will be of 12%. Okay, of 12% of 360. Okay, so that means what? In other words, I'll show you. See, this thing will be 360. Agree? Simple school max. Do you agree, guys? Circle 360 degrees,
Yeah.
right? So now overall 360, the first one G1 is 12. That means what? This G1, okay, this only this part will be 12. How you are going? This 12, what? 12 of 360. Fine. So 12 of 360 will be how much, guys? Quickly. Okay, 360 into 12, 360 into 12 divided by 100. Okay, 43.2. Okay, so this degrees, so this will be of 43.2 degrees. Agree? And this will be of G5. What is G5? The last one, 12. So this is also same. This is also 43.25. Okay, and this G4 is 38. Okay, so 38 of what? 38 of 360 degrees. Okay, 38 of 360 degrees. So how much that will be? 38 into 360. Okay, by 100. Okay, 136.8. Okay, this will be 136.8. Okay, similarly this and this. So overall will be 360. Okay, So in this way, you can also understand how many degrees this is. Okay. So when this will work, when the overall values are summing up to 100. Okay, 100. So then the 360 degrees will be considered as a 100%. Okay. Why I'm telling you this is, if it is not summing up to 100 or 1, in other words, okay. So over here, if you see, I'm having a partial. So by 2, 3, 4, 5, 6, 7. Okay. So if you see, if you sum up this 2, 3, 4, 5, 6, 7, it will 0.7. That means 70% only. Okay. It is not summing up to 100. So in that case, it will plot a partial plot. Okay. So G1, G2, G3, G4, G5. Fine. So it is not summing up to 100. Okay. That's how it is plotting to the this one. Okay. But for example, if I take it as 100, so what I should do to make this 100, guys? Make this as 4, 4, 5, 6, 7, 8, 9, 10. Okay. See, now when I do it as 4, it has filled up the graph. Getting? So if I just make it as 3, there will be a small piece. This small piece is of 10%. Okay. Why? Because this is 3, 4, 5, 6, 7, 8, 9. Overall 90%. On the remaining 10% is pending. This is 10%. Okay. This is a partial pi. Getting?
Yes, sir.
Okay. So after that, there is also another thing called a start angle. Simple. It's very simple. So that means what? So the way how it is plotting, see the same G1, G2, G3. See, just try to understand. Let's say the actual full graph. Oh, yeah. So this one, it is starting here. G1, G2, G3. What is this counterclockwise? Yeah, this counterclockwise. But by default, what is this? By default, this is a graph. Okay. So G1, G2, see G1, G2, G3, G4, G5. This is what this is actual counterclockwise. But I can start the G1 here also, right? So I can say starting from here, G1, G2, G3, this is also counterclockwise. Agree? Or I can start it from here also, G1, G2, G3, this is also counterclockwise. Okay, anyway, the starting position of G1 could be anywhere. Agree? Everything will be the counterclockwise. Okay, but where to start? Okay, G1 can start here or here, or where to start, that you can control by the start angle. Okay, so when you say start angle equal to 0, that means the x-axis, this will be, it will be started over here. So this is a start angle equal to 0. That means it will from the x-axis. Okay, usually we have this is x-axis, right? This is y-axis, right? So when I say start angle equals 0, that means this line, whatever you are having, so that will be that angle with respect to x-axis will be 0. That means it will be almost equal to or in parallel to x-axis. Okay, so over here it will start G1, G2, G3. Okay, so don't worry if I just change this to, let's say, some 30. So now you see, now G1 is sorry, now the graph, this line, okay, so is not parallel to x-axis, so it is having, so if I extend this, so this will be 30 degrees. Getting? For example, if I do it as 90, see, if you see over here, the starting of this axis, okay, this axis is having, what is this x-axis? This is x-axis. So this is x-axis, and this is the main starting G1, G2. What is this angle? This will be 90. Do you agree?
Yes, sir.
Are you guys following really?
Yes, sir. Following.
Okay, fine. So it is very simple. There's nothing difficult to understand. So the only the wherever you're starting the G1, G2, right? So this particular the line. So this line, what should be its angle with the x-axis? Okay. So you can do anything 45. If I do 45, it will be, see, fine. So this is the line, and this is our x-axis. So obviously this will be 45. Fine. So that you can control. Okay. So it's not mandatory you will use everything. So but just we are studying all of this. Okay. The one more thing is the radius. Okay. What is the radius? The size of this graph. Okay. So if it is one, the same graph, if I draw it as 1, for example, where it is radius, yeah, radius, it is 1. If I change it to 10, for example, okay, see 10, we got very big pi. Okay, so 2 is somewhat here, and let's say 0.5, a small pie chart. Okay, and so let's say 5. Okay, you can just change it. Okay, so let me put it as 1. That's better. Fine. So it's just the size of the radius of this graph. Cool. Next thing is something interesting actually. It's called explode, guys. Okay, it's called explode. What is explode? See, these are the graphs we are having. Okay, but I want to separate certain pieces from this pie chart. Okay, I want to separate certain pieces from the pie chart. How I can do that? Why we want to do that? It's none of the point, I would say, as of now. Okay, due to some reason I want to separate only for a particular year. Okay, same example, Cadbury example only. This is G1. Okay, this is Q1, Q2, quarter 1, quarter 2, quarter 3, like 5 quarters. I'm dividing a year into 5 quarters, and I want to separate the biggest part. Okay, the biggest sales wherever, let's say from February month, okay, it is having the highest sales. So that particular piece, I want to separate it out from the other graphs. Okay, getting the idea? So if I want to do that, so the parameter is explode. Okay, so I hope you are observing what we are doing. So the same thing. So AX, from subplots we are using AX.py. Okay, so over there we are passing the value and labels. The only new parameter that is adding every time is over here. This here it is explode. Okay, here it is radius. Okay, so and here it is start angle. Getting? Here it is normalize. Okay, here it is counter clock. Same thing, everything will be same. Okay, so now explode. So when you do explode, it is exploding. That means, see, the name is also very like what do you say? Symbolizing. Okay, so it is just like exploding. The graph got exploded and got separated. Okay, so which one is exploding, you need to understand. Okay, so over here if you see, see G1, G2, G3, G4, G5. Okay, let me take a different color. Yes, yeah. So G1, G2, G3, G4, G5. Okay, these are the values. But the explode, see, for the explode, you are passing this explode. So what is this explode? See, which one you want to explode? All are 0, but only this particular value. Which one is this fourth one? That means G4. Okay, G4 is exploding by how much? Just 0.1. Okay, so that's why if you see G4, this particular value is exploded with 0.4. Sorry, 0.1, a small separation. Getting? But if I just increase this 0.2, it will be still more exploded, a bit more. Okay, so if I increase much more, okay, 0.9, so it is much more exploded, much more separated. Getting, guys? Simple. So you can also use it for different columns also. For example, I want to explode G2 also. Okay, so now this is G2, I will say 0.1. Now G2 is also exploded. Clear? Fine. So, but if you want to explode everything, that is also possible. 0.1, 0.1, 0.1, 0.1. Okay, so you can just play with the graphs. But I want to explode G1. I want to explode it much more. Go little further. Okay, see G1, it is moving away. Fine. You can clearly play with the graphs. Is this clear, guys?
Yeah, Santosh.
Okay, and after that, very simple, add a shadow. Okay, when you say shadow equal to true, it will just add a shadow sort of thing. Okay, nothing much. Okay, to just add a shadow sort of thing. Okay, just for better way of looking. That's it, guys. Okay, so then after that, you can also say frame equal to true. When you say frame equal to true, it will just give a frame and it will plot the values. Okay, it will give the scale. Remaining everything will remain the same. Okay, and after that, there we have something called as percentages. Okay, so after that we have something called percentages. Okay, so you can also mention the percentages. Okay, see over here, G1, G2, G3, G4, G5. So and these values. Okay, so here you are also plotting the values inside them. Getting? Using the auto CPT. Okay, so there's a parameter. So when you mention this, it will also plot the percentages. Okay, but since they are summing up to 100, right? Okay, fine. And also where you want to plot, if you don't want to plot them inside the graph, okay, if you want to just plot it outside, you can also have this PCT distance. Okay, 1.1. So it will just be away from the graph, a bit away. So but if you change this, for example, if I put 10, it will plot somewhere. Oh, sorry. See, so 1.1 is this. Let's say if I do it for 4.1. Okay, so it is these are very small. I think the values are very sensitive. Okay, so sorry. Yeah, so 1.1. If I just go for 2.1, yeah, so see, they're moving away. Okay, I think they're very sensitive. So if I say just 1.5, that should be more than enough. Okay, 1.5 is also more. Okay, 1.2 should be good. Yeah, 1.2 is good. Okay, the how it should plot the way the positions of that. Okay, and this is for the values. Okay, now you can also do same thing for the labels also. So G1, G2, G3. Okay, the labels also you can also decide. So 0.9 I'm saying. Okay, so or if I go it for 2, the labels, see they're moving away. Or if I just say 0.1, they will again come closer. Okay, or just exact 1 should be, yeah, 1 is on it. Okay, just 1.1 can be good. Yeah, 1.1 is good. The labels, earlier it was for the values. Okay, now it is for the labels. Okay, the way, see over here, so I'm specifying here labels equal to labels, my labels, I'm plotting that, and that is the distance. Okay, for the labels, but here I'm not specifying any labels. I'm going for the auto CPT, which will plot the these values. Okay, and this is its distance. Getting, guys? Okay, and another thing is labels rotation. Very simple. So labels rotation equal to true, in the sense it will just rotate the labels, otherwise it will be G1, G2, or else you can rotate the labels also. Simple. And pie chart colors, yeah. So coming to colors, so you can also mention G1, G2, G4. It's the same thing, or for each value you can give some colors. Okay, see, labels equal to, I'm plotting the labels, and also colors equal to colors. From where I'm getting this colors, this particular plot. Okay, this colors, fine. So over here you can specify, these are the different colors. Okay, you can specify any colors. For example, yesterday we have seen some colors, right? So let me pick it from that colors. Okay, for example, this pink color, if I take, okay, so let me just, yeah, so for example, let me put it as for G4. Okay, yeah, can you see pink color? Fine, this is colors. So there are many color codes which you have already seen in the documentation. Use any color code. Okay, that will work. Just mention the color parameter. After that, the border color. So this is just for color, and this border is black, right? So if you want to change the border color also, you can go for the border color. Okay, so color is color. Okay, so for the border color, this edge color. Okay, so and also width. So edge color is red, it is saying, and the width is 2. But if I go for the green, I see the green and width is 2. For example, if I go for width equal to 5, it's a very thick one. Fine. And also I can use this particular G4 over here, and for here I can use some, if I use G4. Okay, see pink. You can also so we are doing everything. We are customizing the actual plot color and the border color, border width, everything. Whatever you see on the graph, you can customize that. Okay, so I can go for some orange. Okay, so sorry, that color. Okay, so orange, so anything is possible. Okay, fine. So again, the same examples. Okay, so you can drop PLT graph, and in the same, yeah, so if you want to go for different colors, as we have seen, so you can also give different colors in the sort of list. Okay, so and that will be plotted. Okay, so yes, same thing it is plotting. Okay, so DF value tips. Okay, so you are plotting it from the tips data set. These are the values, and names equal to day. Okay, so which day you want to see, so it will also show it in the legend format. Okay, and the last thing is this one last thing is, till now we are you might have observed that the background was changing, right? So that is due to this, guys. Okay, because we have so many styles available in the Matplotlib. So these are the different styles. Okay, see, ggplot, dark background, classic, etc, everything. Okay, for example, if I'm plotting this is a simple histogram. Okay, simple histogram. Okay, so if I use and this particular is due to the classic. Okay, the background class is classic. So if I use it from some Seaborn, okay, so they will see the background is somewhat different. Getting, just observe. So if I use something called as dark background, okay, so if I use something on dark background, if I just set, you need to just set it plt.style.use dark background, and now if I run this, see, it became dark. Are you able to observe, guys? If I use ggplot, this is a thing. Okay, each of the style will have different color codes. Is this clear, guys? Everyone?
Yeah, Santosh.
Okay, so that's all. But one last very important thing, don't miss this, is how to save the graph. Very simple. So let's say we are plotting all these graphs, that's fine. Okay, but if you lose this notebook, it will be lost, right? So how to save? It's very simple. Okay, so here we are plotting a graph. One thing you need to do is plt.save save figure. Okay, so you do that and sample.c. This plt is what is having your graph. Okay, so that plt.save fig, if you do plt.save fig and give some name, okay, when you run this, okay, so it has saved my sample.png. So if I go over here, okay, and if I check on this one, okay, see the sample.png. Okay, see, this is a graph what is got saved as sample png. Okay, so I would like to save some pie graph. Okay, so for example, this is my plot. Okay, so let me save a simple plt. Yeah, so this is my simple plt dot pie graph. So over here I want to save it as plt dot save fig. Okay, and pie, I'm using some png. Okay, so once I save this, if I go over here, okay, and as you can see, pie easy.png. Oh, what happened? They missed something. Just give me a second. plt.save fig sample.png. It should work actually. Just give me a second. Big sample. Okay, let me try to save some other graph. Okay, so let me take this. So over here, plt.save fig bar graph dot png. Is it because the background, did we use it as completely black or what? But here it worked, right? So here it worked. Sample.png. Okay, so if I go with the sample.png, yeah, I'm able to get sample.png. Let me just use the different background. So it's just, it will be just with the background. So okay, don't worry. Let me use some classic. Okay. Okay. And now, where was that? Bar graph underscore png. Is it because of fine guys, I will check this out. Actually, it should save just like how we have just seen the bar graphs. Okay, but for the plot saving of this giving some issue, but don't worry, we'll check this out in tomorrow's class. Fine, so that's about the plotting, guys. Okay, so this is mostly about the matplotlib. Okay, so I would say we have covered all the required graphs, starting with the simple line graph. Next we have seen the scatter plot. Next we have seen the bar graph. Next we have seen the histogram. Next we have seen the pie chart, different combinations. Okay, so this should be more than enough for you to draw any of these graphs. Okay, so that's about the matplotlib. Okay, if I just go to matplotlib. Okay, now in tomorrow's session we are going to see something called as yeah, in matplotlib itself. Okay, sorry, we have in matplotlib only, I think we have a few other graphs. Okay, let me take a quick look. Okay, so after finishing those, we are going to go for the seaborn. Okay, seaborn is a bit more advanced and you will have very interesting graphs. Okay, till now what we have seen are very basic graphs. Okay, simple one univariate or histogram, one simple pie chart. Okay, these are very simple. Okay, but in practical use case, right, so we will mostly use seaborn. Okay, because to find out heat maps, okay, pair plots, okay, or distribution graphs. Fine, so you might have observed in our statistics we were using seaborn. I told you that we are importing seaborn as SNS, and there we are using pair plot. Okay, the complete data frame to convert it into different graphs, correlation graphs. Okay, all those we are going to see it in the seaborn. Okay, so that will be a little more advanced and a little more interesting also. Okay, so that is a plan actually. Okay, so yeah, so the idea is to conclude today's 17, right? 18, 19. Yeah, mostly by Friday or else in case Saturday. Okay, in this weekend we are going to conclude the visualization module. Okay, and next week we are going to start with the next module called as feature engineering and then EDA. Okay, those two things. Okay, after visualization, next will be feature engineering, and next thing will be the EDA. Okay, so once we do this, right, mostly by next week, just in case I'm taking maximum this month. Okay, it should not be that. Okay, because feature engineering will be 3-4 days and EDA will be 4-5 days. Okay, yeah, we can decently take few more extra use cases and understand EDA. Okay, fine. Okay, so by this next week or this month, then we are going to cover these two important. Okay, these are actually into the machine learning concepts only. Once we do this, right, and assuming that you are good with what we have discussed so far, at least 70 to 80% of the modules which you have discussed, like stats, NumPy, pandas, visualization, feature engineering, EDA, you are very well prepared to start with the actual core concept of this course called as machine learning. Okay, so that mostly I will try to start few concepts by this month end. They will take 1 or 2 classes, but for sure we are going to start it from the Feb, or mostly I will try to start it in this week. Okay, and we'll cover a few models. Okay, fine. So that's all, guys. Okay, that's all from my end today. Okay, thanks for joining and extending. Okay, so I'm going to share this notebook, Python, visualization, Matplotlib. Okay, and the required Excel files also. Very simple. Okay, no difficult at all to understand. Okay, try to spend some time, play with these graphs. Very interesting. Okay, I'm telling you, this will be very, very helpful when you are trying to work on projects. Okay, it will be very helpful. You will understand that. Okay, fine, guys. Okay, any doubts? Are we good?
Yeah, Santosh. So, Santosh, able to hear me?
Yes, yes.
That style, you have run one cell, right? Style.
Hmm.
Yeah, that style one will applicable to entire page or only specific?
Entire. So see, that's what the good point. So when you are saying PLT, right? So
Yeah.
what is this PLT? We are taking it from Matplotlib, and
Yes.
you're using the same PLT to plot here also.
Yes. Yes. Yes.
So
Yeah.
that will be applicable. Okay, whatever you are setting that style, right? So that will be applicable for every graph you do.
Oh yes. Okay. Yeah.
Okay. So because that's the same parameter from the Matplotlib you are using, PLT. Using this PLT only, you are drawing the graph using this PLT only, you are showing using this PLT only, you are saving. Okay, so that's why when you set this, it will be for the every thing. Okay, but if you want different plots, right, first set this, draw histogram, again come here, set this, draw bar graph, again set this, draw plot. Okay, so it will have different backgrounds. Getting? Because once you do this, it will not change it again, right?
Yes. 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 Santosh, got it.
Okay, that's the point. Okay, fine. Are you good, Meghana? Any doubts? Did you follow?
No, sir, no doubts.
You did not follow?
I followed, sir.
Okay, cool. Okay, chalo guys, tomorrow we are going to see how to save also, and the next concept. Okay, fine guys, thanks for joining. Chalo, bye.
Yeah. Thanks, Santosh.